Good day and welcome to this tutorial. In this video, you will learn variables and data types in Python. At the end of this video, we are going to build a mini project. Putting the knowledge of variables and data type we've learned in this video together, we are going to build an expense tracker. I hope that is something you'd love to do, right? Alright, let's jump right into the video.
Let's start this section by a discussion of variables, which are one of the core concepts in programming. We use variables to store data in computer's memory. Here are a few examples. I'm going to define a variable called students_count and setting it to 1,000. When we run this program, Python interpreter will allocate some memory and store this number 1,000 in that memory space. Then it will have this variable reference that memory location. So this variable is just like a label for that memory location. We can use this variable or this label anywhere in our program to get access to that memory location and the data stored there. So now if we print students count and run our program, we will get the number 1,000. So this is the basic of variables. Now, what kind of data can we store in computer's memory? Well, we have several different kinds of data. In this section, we're going to look at the built-in primitive types in Python. Primitive types can be numbers, booleans, and strings. Let me show you. So here we have a whole number. We refer to this as an integer in programming. We can also have numbers with a decimal point. Let's take a look. So rating, we set this to 4.99. This is what we call a float or a floating point number. And this terminology is not specific to Python. In the future, when you learn a new programming language, you're going to hear these terms again. Now let's take a look at an example of a boolean. Is published, we set this to true or false. These are examples of boolean values in programming. So boolean values can either be true or false, and these are exactly like yes and no in English. Later in the course, you will learn that we'll use these boolean values to make decisions in our programs. For example, if the user is an admin user, perhaps we want to give them extra permissions. So these are the boolean values. Now take into account that Python is a case-sensitive language, which means lowercase and uppercase characters have different meanings. So boolean values should always start with a capital letter, like what you see here. If we type false or false, these are not accepted boolean values in Python. Only what you see here is a valid boolean value. So false or true. And finally, let's take a look at an example of a string. So course_name, we set this to a string like Python programming. So a string, as I told you before, is like text. Whenever you want to work with text in your programs, you need to surround your text with quotes. So these are the basics of variables. So these are the variables from the last lecture. Now I've got a question for you. There are 4 things that I have consistently used in this program. Can you spot them? If you want, you can pause the video, think about this for a few seconds, and then continue watching. So here are those 4 things. The first thing is that all my variable names are descriptive and meaningful. So students count represents the number of students for a course, or course name clearly explains that this variable holds the name of a course. One of the issues that I see a lot amongst beginner programmers is that they use mystical names for their variables. Something like this, CN as in short for course name. When someone else reads this code, they have no idea what CN stands for. Or they use variable names like C1. When I look at that code, I wonder, where is C2? And what is the difference between C1 and C2? So these variable names are very mystical. That's a bad practice. Make sure your variable names are always descriptive and meaningful because this makes your code more maintainable. Now, there are times that you can use short variable names like X, Y, Z if you're dealing with things like coordinates. So that's an exception. Now, the second thing that I have consistently used in this code is that I have used lowercase letters to name my variables. So here we don't have course name all in capital or in title case. All letters are lowercase, right? Let's delete these. The third thing that I've consistently used here is that I have used an underscore to separate multiple words. And I've done this to make my variable names more readable. Because in Python, we cannot have a space in variable names, so we cannot have course name. And if you put these two words together, it's a little bit hard to read. That's why we use an underscore. And the fourth thing that I have used consistently here is that I have put a space around this equal sign. Again, that's one of the issues I see a lot amongst beginners. They write code like this. This is a little bit ugly. This is what we call dirty code. Dirty, stinky, smelly. You should write code that is clean and beautiful, so other people can read it like a story, like a newspaper article. It should be formatted properly, and that's why we have PEP8 in Python. Now, the good thing is, if you forget these rules, when you save the changes, auto PEP8 kicks in and it automatically reformats your code. But that aside, you should always give yourself the habit of writing clean code without relying too much on the tooling. So these are all the best practices about naming your variables. Next, we're going to look at strings in more detail. In this section, we're going to look at the built-in data structures in Python, which are extremely important when building real applications. First, we're going to look at lists, and then we'll look at tuples, sets, and dictionaries. So earlier you have seen that we can use square brackets to define a list or a sequence of objects. In between these brackets, we can have objects of any type. So we can have a list of strings like this, and then assign it to a variable like letters. We can also have a list of numbers, booleans, or even a list of lists. Let me show you. So here we have a list. Each item in this list will be a list itself. So here's the first item, which is a list of 2 items. Now let's add another item to our main or parent list. This item is also a list with 2 items. So now we have a matrix, which is a 2-dimensional list. Now let me show you some cool tricks. Let's say you want to have a list of 100 zeros. You don't want to manually create that like this. That's very ugly. Let me show you a better way. So we define a list of 1 item, 1 0, and then we can multiply it by 100. And the result will be this. Let me show you. Print zeros. Here it is. There you go. So using a star or an asterisk, we can repeat the items in a list. Now similarly, we can use a plus to concatenate multiple lists. Let me show you. So first I'm going to change this to 5. Now let's define a variable combined, which is our zeros list plus letters. Let's see what happens. Print combined. You know it. So we have 5 zeros followed by A, B, C. As you can see in Python, every object in a list can be of a different type. So they don't have to be exactly the same type. We can combine a list of numbers with strings and booleans or even lists. Now let's say you want to have a list of numbers like 0, 1, 2, 3 all the way up to 20. You don't want to type all of these by hand. There is a better way. So we have this list function. As you can see, this function takes an iterable. So we can pass any iterable here and convert it to a list. Earlier you learned about the range function. This function returns a range object which is iterable, which means we can iterate or loop over it. So here we can call this function and pass 20. And with this, we can create a list of numbers from 0 to 20. Let me show you. So let's store it in numbers and then print it on the terminal. There you go. So 0 up to 20. But note that 20 itself is not included. As another example, let's call the list function and pass a string. Earlier, I told you that strings are also iterable. We can loop over them. So we can pass them to the list function and see what we get. Let's print chars on the terminal. So you can see each character in our original string is an item in this list. So these are a few different ways to create a list in Python. Now that we have a list, we can get the number of items in that list using the len function. So here we can print the len or length of chars. Let's take a look. So we have 11 items in this list. Over the next few lectures, we'll look at various operations around lists. So here we have a list of 4 items. We can use square brackets to access individual items in this list. So let's print letters of 0. This will return the first item in this list. So when we run this program, we'll get A. Now, similar to strings, if we pass a negative index here, like -1, this will return the first item from the end of the list. So when you run this, we'll get D. Using square brackets, we can also modify items in the list. So let's change the first item to a capital A and then print the entire list. There you go. So this is the basic of accessing individual elements in a list. Now, earlier in the course, you learned that we can use 2 indexes to slice a string. We have the exact same concept here. So we add square brackets, first index, colon, second index. And this will return a new list with the first 3 items in our original list. So if we print our original list, you can see that it's not changed. Now, just like strings, if you don't specify the first argument, 0 will be assumed by default. So as you can see, these 2 expressions produce the exact same result. Similarly, if you don't include the end index, by default, the length of the list will be used here. So this expression will return a new list with all the items in the original list. And similarly, we can also exclude the start index here. And with this syntax, we can get a copy of our original list. There you go. Now, when slicing a string, we can also pass a step. And this is useful in situations where you want to return every second or every third element in the original list. So now when we run this code, we'll get A and C. So B will be skipped. Let me show you using a better example. So I'm going to delete everything here. Create a new list called numbers. Here we're going to use the list function and pass range of 20. Let's print our list. So we get numbers 0 to 19. Okay. Now let's see what happens when we add square brackets here with 2 colons and 2. This will return every other element in the original list. Take a look. So we get all the even numbers, 0, 2, 4, and so on. That's pretty cool, isn't it? Here's another cool thing you can do here. Let's change the step to -1. As you can see, this will return all the items in the original list, but in reverse order. So these are some useful things you can do with lists. Next, we'll look at unpacking lists. There are times that you may want to get individual items in a list and assign them to different variables. Here's an example. We can define a variable like first and set it to numbers of 0. Similarly, we can define second, set it to numbers of 1, and third, set it to numbers of 2. Perhaps you're going to use these variables in a few complex expressions in your code. Now, there is a cleaner and more elegant way to achieve the same result, and that is what we call list unpacking. So we can unpack this list into multiple variables. Let me show you how that works. So we define our variables like first, second, and third, and then set them to our list. What we have on line 2 is exactly identical to what we have on lines 4 to 6. This is what we call list unpacking. Now, what is important here is that the number of variables that we have on the left side of the assignment operator should be equal to the number of items we have in the list. So if we exclude third here and run this program, we will get an error. Value error, too many values to unpack. So there are too many items in this list and we cannot unpack it into enough variables. Now, what if in this list we have so many items, but we only care about the first 2? We don't want to define so many variables on the left side of the assignment operator. Well, we can get the first and second, and then pack the rest inside of a separate list called other. With this syntax, we'll get the first and second items, and everything else will be stored in a separate list called other. Let me show you. So let's print first, and let's also print other. Now we don't need these few lines here. Let's run this code. So first is 1, and other is a list of all the items after the second item. That is the list I'm talking about. So in this example, we have both unpacking and packing. First, we try to unpack this numbers list into the variables on the left side of the assignment operator. And then because we have used an asterisk here, we're basically packing all the other items into a separate list. Now, to refresh your memory, earlier we used this syntax when defining a function with a variable number of arguments. Remember? We had a function like this, multiply, with a parameter called asterisk numbers. And then we could call this multiply with an arbitrary number of arguments. So when we prefix a parameter with an asterisk, Python will get all these arbitrary arguments and pack them into a list. This is exactly what is happening on line 2. Now let me delete this other stuff. Now let's change this example a little bit. What if we care only about the first and the last item? Well, we can put other in between, so we get the first, other, and then the last item. So let's change the last item to 9, and then print first, last, and other. This is what we get. So first is 1, last is 9, and the rest is here. So this is all about list unpacking. In this lecture, I'm going to show you how to loop over lists. So here we have a list of 3 items. We can use our for loops to loop over this list. So for letter in letters, colon, and then we print each letter. Save the changes and run the code, we get A, B, C. Now, what if we want to get the index of each item as well? Well, we have a built-in function called enumerate. We call it here, and this will return an enumerate object, which is iterable. In each iteration, this enumerate object will give us a tuple. Let me show you. So now when we run this code, look, in each iteration, we're getting a tuple. So a tuple, as I told you before, is like a list, but it's read-only. We cannot add new items to it. So in each iteration, we're getting a tuple of 2 items. The first item in this tuple is the index, and the second item is the item at that index. So now to get the index, we can use square brackets to access the first item in this tuple. So if we print letter of 0, we will get the indexes, and right next to that we can add letter of 1. So we will see the item at a given index. But this syntax is a little bit ugly. In the last lecture, you learned about list unpacking. So if we have a list with 2 items, 0 and A, we can unpack it into 2 variables like this: index, comma, letter equals items. So here we are unpacking the items list. Now, what if we change square brackets to parentheses? Now we have a tuple, and we can still unpack this tuple. So you saw that this enumerate function returns an enumerate object which is iterable. In each iteration, this enumerate object will return a tuple that looks like this. So we can unpack it right here. So we add another variable, index. Now with this, we no longer have to use square brackets, and we can simply print index and letter. Let's run this code. There you go. So now we don't need this anymore. So to recap, you can use for loops to iterate over lists. If you also need the index, you should call the enumerate function. This will return an enumerate object, which is iterable. In each iteration, it will return a tuple, and you can unpack that tuple right here. In this lecture, I'm going to show you how to add new items to a list or remove existing items. So for adding items, you have two options depending on where you want to add this new item. If you want to add an item at the end of the list, you should use the append method. So, earlier you learned that everything in Python is an object, so you can use the dot notation to access individual functions, or more accurately methods, in that object. So when a function is part of an object, we refer to that function as a method. So here are all the methods available on list objects. We use the append method to add something at the end of this list. Let's print our letters and we will get A, B, C, D. Beautiful. Now, if you want to add an item at a specific position, you should use the insert method. So letters.insert, we can add something at the beginning of the list, so index 0. Let's add a hyphen and then print the result. So this is what we get. Now for removing objects, again, you have a few different options. If you want to remove the item at the end of the list, you should use the pop method. So here we call letters.pop. This will remove the letter D at the end of our list. So now let's print our letters. As you can see, D is gone. You can also pass an index here to remove the item at the given index. So if we pass 0, instead of D, this hyphen will be removed. Let's take a look. We run this. So the hyphen is gone and we get A, B, C, D. Beautiful. Now there are times that you want to remove an object, but you don't know its index. If that's the case, you can use the remove method. So letters.remove. Here we can remove B, and this will remove the first occurrence of the letter B. So if you have multiple B's, only the first one will be removed. If you want to remove all B's in this list, you will have to loop over this list and remove each B individually. Now let's run this code one more time. So you can see B is gone. We have another way to remove an item from a list, and that is using the del or delete statement. So here we can delete an item by its index. We can also delete a range of items. So this is the difference between the delete statement and the pop method. The pop method will remove only one item by index, whereas with the delete statement, we can remove a range of items. And finally, if you want to remove all the objects in the list, you should use the clear method. Next, we'll look at finding objects in a list. There are times that you want to find the index of a given object in a list. So let's say we want to find the index of letter A in our letters list. We call letters.index and pass A. Let's print the result. So this will return 0. What if you try to get the index of an object that doesn't exist here, like D? We get a value error. D is not in the list. This behavior is different from a lot of programming languages out there. C-based languages return -1 if you try to get the index of an object that doesn't exist in the list. But in Python, we get an error. So to prevent this error from happening, first you should check to see if the given object exists in the list. And for that, we use the in operator. So if D is in letters, then we will print its index. So now we run the program and we don't get any errors. We also have another method that you might find useful in certain situations, and that is count. So letters.count. This will return the number of occurrences of the given item in this list. So when we print the result, we'll get 0.